Well, hey Marine, hope you're doing well when you watch this video. This is going to be the last part of chapter 16 about food webs. We just need to talk about biogeochemical cycles. So I want to show you this picture right here. Some of it's off the screen, so let me bring it down a little bit. But you actually have a cycle running in your body every single day called the circadian rhythm cycle. And there's been some debates about exactly where all these times are, but I just want to point out one specific one for you. Every day your body is going through a cycle that involves melatonin. Some of you actually might take melatonin to help you sleep. It's a hormone that helps us shut down. But your body naturally starts secreting it around 2100 hours, which is, minus 12, that's 9 o'clock roughly, right? And then around 7:30 in the morning, the secretion stops. And so your body's undergoing a cycle every single day. And there's so many cycles in nature. There's a little old comic strip from Peanuts. It says that children like to be part of a definite routine. That's true, that's true. At least that's the way I've always felt, just as long as it isn't the same old routine. We're definitely in a routine right now. I'm not sure if you've already fallen into a routine every day. You get up at this certain time and you eat this for breakfast, or you don't eat breakfast, and you do your work for a certain class first and a certain class second. But we all are creatures of habit. We all like, routines safe. It kind of feels, safe to understand what's about to happen. But in nature, there's also kind of cycles. There's also routines that kind of go on. And so matter moves through the ecosystems in a recycling way. Energy is a one-way stream, right? Once it's neither created nor destroyed, and once it's used, it's used. And so these are called biogeochemical cycles. I'm going to talk about a few of them in this video, okay? Biogeochemical cycles, which obviously they're powered by the flow of energy, of course. So if energy is not around, you wouldn't be able to, these cycles wouldn't be able to run. And so a biogeochemical cycle moves through both biotic, which is living, the biosphere, and abiotic, the lithosphere, the atmosphere, the hydrosphere, compartments of the earth. So biogeochemical, bio-earth, bio-life, sorry, geo-earth, and then chemical, of course, meaning chemical reactions. And so they move through all those different processes. So biological processes such as eating, breathing, burning food, eliminating waste, we do these, of course. We're humans, we're alive physically. So I hope you're alive spiritually, of course, according to the Bible. But nonetheless, this is eating and breathing. Geological cycles is like lava or magma flowing or plate tectonics, anything that's involving the earth. Chemical reactions could be, formation of clouds or the flow of running water, the action of lightning. All of these are examples of chemical processes. But there's also one more that we have to take into consideration since we live in the age of humans. Human activity. And we've talked a lot about it. I won't go into this video, but we are definitely influencing biogeochemical cycles through our burning of fossil fuels and our use of the land and various things like that. So let's just go through a few of these cycles together. I'll point out a few things that you should know. So first off, this is the water cycle. You've been learning about the water cycle since you were in elementary school, I'm sure. But a few words you need to know. Of course, precipitation is, rain, snow, hail. So evaporation is liquid to gas, okay? And then condensation, if you've ever seen condensation on the outside of your sweet tea glass outside on a hot summer's day, you know that that's gas to liquid. You have evapotranspiration, which is evaporation from plants. You also have runoff and infiltration, which go into the earth, of course. I want you to see that groundwater is very important to feed, springs and these living ecosystems. Okay, so I would know all those terms for sure about the water cycle. Moving on is the next one is the carbon cycle. Okay, so carbon is necessary for life. We're carbon-based life forms, and so let me point out a few things. So first off, CO2 is in the atmosphere, of course. So burning fossil fuels and burning just naturally, fires and stuff, increase those CO2 loads in the atmosphere. Respiration does as well because we breathe in oxygen and release CO2. But respiration and photosynthesis are opposites. I want you to see that. So if respiration, gives it back into the atmosphere, photosynthesis takes it out and puts carbon in in different forms inside of plants and photosynthetic organisms. So if respiration puts it into the atmosphere, photosynthesis takes it out. Of course, phytoplankton is a source of half of our oxygen, so they use it. So, if they die and sink to the bottom, you can have sedimentation, of course, sediments and sedimentary rock, and then that eventually over thousands of a long time produces those coal, oil, and gas. When you burn oil, you're just burning dead organisms from the past. And so that is an example of the carbon cycle that you should be aware of. The next thing is nitrogen. Nitrogen is extremely important because we need it in proteins, we need it in DNA to make DNA and proteins correctly. And so nitrogen is abundant in the atmosphere, but we have no biochemistry inside of our bodies to take it out of the atmosphere and incorporate it into our systems. We have to eat it. And that's an issue because it's so desperately needed by our body. So what helps us out? Well, actually bacteria helps us out. Bacteria get a bad rap, but most of them are good for us, or not dangerous for us. There are of course the ones that are dangerous, but nitrogen fixation is done by bacteria, and that allows nitrogen to get into the food web systems that we're a part of course, and so therefore we're able to ingest it. Of course, here's human activity, right? Fertilizers can run off into oceans and rivers, and that of course causes a lot of possibly proliferation of certain organisms and algal growth, that and phosphorus. And so let me show you another picture here about the nitrogen cycle. So this is a better picture about bacteria, okay? So nitrogen is, again, is very high percentage in the atmosphere. And so nitrogen fixing bacteria take that atmospheric nitrogen and transfer it into, here it is, ammonium. You don't have to know these terminologies, but just see the process right here. And then nitrification is nitrites, and those nitrites are able to be assimilated into plant tissues. They absorb it from the soil. So that's what fertilizer has, of course. When you put fertilizer in your yard or on plants and stuff, that's what you're doing. You're adding nitrogen and various other essential nutrients to allow plants to have that ability to grow larger and healthier. And so a bacteria is necessary for that in the river world. And then how does it get back into it? Well, there's also the other side of life. Nitrifying bacteria returns it back into the environment, okay? The last cycle that I want to talk to you about today is the phosphorus cycle. We need phosphorus because sugar phosphate backbone in DNA, in our DNA, so we need that. We are desperate for phosphorus. And so what's interesting is that phosphorus is mostly in rocks. And so it's slower process than all these other processes. But let me show you a better picture from I believe it's from the USGS services, yeah. But here we go. So most of the phosphorus is in rocks. But over time that gets weathered down, right? Rocks break down, weathered down. And so that gets dissolved into the soil, which is then, there it is, input into those terrestrial food webs, which we're a part of. Sometimes phosphorus can be released as an aerosol, but mostly it's done this way through the rocks and stuff, and so it can be dissolved in streams. And here's humans again, fertilizers and runoff, and that can lead to, again, that proliferation of sometimes algal overgrowth and destroying systems because of our not wise, I guess, not being a very good steward of where our fertilizers are going when we use them. But not everybody does that, just some, so. But again, this is the phosphorus cycle. So again, I would know those, terminologies for those 4 cycles for quizzes and the test coming up. I would know about the water cycle, the nitrogen cycle, the carbon cycle, and the phosphorus cycle. I would know why they are important and the various terminologies that go along with them. But until next time, guys, I hope you're doing well. Stay encouraged. If you ever need anything or want to kind of vent, all your teachers, including myself, are here for you. So please reach out if you don't go through this alone. If you're dealing with really some struggles or some questions, please reach out. Life is meant to be shared together, and we can still do that even if we're not allowed to be more than 6 feet close to each other. We can still do it. So anyways, reach out if you have questions, guys. Much love. God bless. Hope you and your family have a good day.